Good morning, good afternoon. We are going into 2.2 today. Oh, wrong one. 2.2, solving two-step equations. Our I can statement is I can solve two-step equations, and then I can write equations needed to solve. Pretty much today, what we're going to be doing. So before we had those one-step equations where we had problems like 3x equals 9. And we just had the one step to undo. And we would divide both sides by what? 3, right? And we would get x equals 3. Or a problem like x plus 7 equals 10, where we had that plus 10, and we needed to undo it by subtracting 10. Remembering our rules of whatever we do to one side, we have to do to the other, and then x would equal 3. Now we're going to combine those two different steps so that it's going to be something like a problem that might look like this. 3x plus 1 equals 10, where we have a coefficient on our x, but then we also have something that's adding or subtracting. So the first thing we need to do is a few vocabulary. Our properties. Properties are just mathematical statements that are true for any number. And then our two-step equation is it contains two operations. We might have to first add or subtract, and then we're going to have to divide. It usually involves a coefficient and a constant term. A constant term, very important. The constant term is a number that is added or subtracted in an equation or an expression. I use the example a lot of, and I'm not going to go talk about word problems in a second, but I want to talk about, like, say, I have something like this where I have to pay $50 a month for my cell phone plus $5 for every movie I download. So my X is going to represent my movies that I download, and I'm going to multiply it by 5, and then I will always be adding that 50. Okay, what is constant? Every month I have a constant payment of what? $50. That is going to be my constant. The number that will vary is the number of movies I get. So that's why it's my variable. It will vary depending on how much my total bill is. Now I'm not, so it's very important to know what the difference between my constant and my coefficient is. The coefficient is connected to the what? The variable. It's the number connected. If I just have an x, I have an invisible 1. Okay, so let's, and always our goal is to isolate the variable so that it is 1x or 1n or whatever. Combining like terms, our first step, any like terms. Before we get too far on that, I want to review. So I'm going to write down 2x, x squared, 2, and 5x. There are 4 different terms here, right? Split them up a little bit. There are only 2 that are like terms. And what are those 2? 2x and 5x. Like terms are the same variable raised to the same power. And that's why this one cannot be, because it has a 2 as an exponent. This one does not have a variable, so this would be a constant. So this could also not be. If I were to draw out, and we're going to work with algebra tiles more on Friday, I think, a little bit, but if I were to draw this out, this would be what my x's look like. And this is an x squared. And then 2 units are just going to be my 2 little units. and then again, 5 x's. When I'm talking about like terms, I like to 2x and 5x. Replace x with apples. 2 apples plus 5 apples equals 7 apples, right? So if I were to combine those, this would be 7 apples, or, oh, you can't see that, sorry, or 7x. Looking at my shapes here, which ones are the same shape? My same like terms, right? The 2x and the 5x. They're the same shape, so that's how we can combine them. That's why you can't combine it with that. Okay? Now, mainly after our combining of like terms, then we are going to add or subtract to get rid of that constant. The constant is not going to be in the same spot every time, but you have to know that the constant does not have a variable. It's just the number. But you do want, so like here in that example that I gave, that 3x, this 3x plus 1 equals 10. I have 2 that kind of look like the constant, right? How do I know which one I get rid of first? Or which one I want to get rid of? Well, I want to do the one that's on the side with my variable. See that? See the difference between 1 and 10? The 1 is on the side with the variable. So the kids were getting confused earlier in earlier classes. So I want to get rid of my constant first, and to get rid of a positive 1, I would subtract 1. So I add or subtract to get rid of my constant, and then I multiply or divide to get rid of my coefficient. So we're going to do a few. Our first example, 5 plus 2n equals -1. Our n is our what? Variable. Our 2 is what? Constant. Not yet. 2 is coefficient. The 5 is the constant. So I'm not even going to worry about that, whatever's behind it. I just look at the 5. How do I get rid of 5? I have 5. I want to take away 5, right? So I'm subtracting 5. I'm not subtracting because it's the opposite of this plus. I'm subtracting because I have 5 and I need to take away 5. Again, remember, whatever I do to one side, I have to do to the other. This goes away. (2n) is left. -1 minus 5 is a -6. You will have positive and negative numbers. Let the calculator do the work. Play around with a calculator so you know how to work with negative numbers. That right here. So -1, oh, not that. -1 minus 5. Was that what it was? Yeah. -1 minus 5, and that will give you that -6. Okay, don't get it wrong just because you can always use that calculator. All right, and then divide by 2 on both sides. So after we get rid of the constant, we are then going to multiply or divide to get rid of the coefficient. Well, right now we're multiplying, so we undo it by dividing. So this goes away. I have n equals a -3. Again, use your calculator. If you can't remember those rules of a negative divided by a positive is a negative, use a calculator to check it. Okay? This one, again, is a little different order, so we have to look for our constant. Our constant is what? The 2. How do I get rid of positive 2? I would subtract 2 on both sides. -19 minus 2, -21. I have a -3x left because this goes away. Divide both sides by -3. Negative divided by a negative is a positive, so +7 equals x. I've isolated my variable, or got it by itself, I know what 1x is equal to, and that is my goal. I am going to continue right on. If you guys have questions, we will go through them in a second. All right, these two now we have fractions again. So this is where we're going to combine what we did yesterday, but we have two steps. So again, we have to see which one is our constant. A lot of kids, and I'm going to do this way just real quick to show, a lot of kids will do, get rid of that -1 by adding 1 to both sides. And it's not necessarily wrong, but they get -1 plus 1 is what?
0.
It is 0. And that equals 1/2 a plus 10, right? And then they say, oh, I have to get it to the other side, right? I need something over here. So you don't want to do that side. That's why you want to get rid of that +9, whatever is happening on the side with that variable. Because that's our goal, is to isolate the variable. So we would subtract 9 on both sides. It's also really good to notice that when we were doing that, we had 0 and we had a 10 over here, right? So if it's 10 on one side of your equal sign and you move just that 10 and it's actually on the other side, it's the opposite sign. So instead of 10, it's going to be -10 on this side. It's just a good kind of quick check to say, what is -1 minus 9? -10, right? And I shouldn't even talk about that because that gets kind of confusing. But so we're going to get rid of that 9, subtract 9, subtract 9. I get 1/2 a left on that side because this goes away. Now, a lot of kids will say, well, it's 5, right? Because they do 1/2 of 10, and that's 5. Go back to this problem. 1/2, you're saying that a is 5. 1/2 of 5, is that 10? No. So how do we get rid of that 1/2? This reciprocal. So we're going to flip it and multiply both sides by that 2/1, which is just 2, right? So we're going to multiply both sides by 2. So 2 times the -10 is a -20. These go away, and I just have a left. And now, what is half of 20? 10, right? Or -10. Okay, this one. This is why I said don't look at what's after your constant. Look at what's before the constant. How do I get rid of 10? -10. Again, let me do real quick the wrong way. Sorry, I just like to show a lot of mistakes, common mistakes that happen. A lot of kids will see a minus here and say, oh, plus 10 on both sides. 10 plus 10 is what? 20. How did I get rid of it? I'm trying to get rid of that 10, and I just made it 20, right? So that's why, oh yeah, I don't add it, I have to subtract it. Okay, so this goes away. 52 minus 10 is 42. What's left over here? -2/3 p. Remembering that negative has to stay with it. Okay, I'm going to multiply by the negative reciprocal. These go away. P is left. So I have to multiply this by -3/2 also. Okay, you have to, and again, don't get confused, but you can simplify first and do 21/1. Oh no. This is -63. Real quick before you have to see the difference between the two here. This is n divided by -3 minus 2, and this one is n plus 3, all divided by 8. On this one, we do plus 2 first, and on this one, you multiply by 8 on both sides first. Okay, so, and then you can solve it like before.